You should have already watched a video on how to actually solve a radical equation. So I'm only going to go through a few of these and you're going to do a lot of them on your own. So we'll look at these two. You'll try the next two by yourself. All right. When you have a square root, if everything is under one radical, in order to get rid of a radical, as long as it is isolated on its own side, I can square both sides. So once you square a radical, it's 2x minus 1, and you square both sides, and it's 10, and x is 5. So you should have been able to do that one by yourself. If we're looking at this one, just be careful if the index is not a square, squaring both sides is not going to be the option. So we need to cube both sides and the index will undo each other and x plus 4 equals, but please remember whatever you do to one side, you do to the other, and 4 cubed is 4 times 4 times 4, and that is 64, and then subtract, and x is 60. When you look at either one of these, they're both similar in nature. The point is that the radical is not by itself on the side. So you want to isolate to get the radical as far as you can. So for example, this is added on, so I'm going to subtract this over and get 2 the square root of x is 6. At this point, this is attached to it. You could square both sides, or you still have the option to get the radical by itself. So what I'm going to do is get this 2 out of here to start, and I will get the square root of x equals 3. Now, had I had this and I squared it, that's fine. You would just get 4x. So you just need to be careful, and a lot of people will mess that up. And here you would get 36. When I do it this way, then I square, and x is 6. And when, sorry, 9. 3 squared is not 6, 9. And when I divide by 4, my answer would also be 9. So either way is fine. The only time I do like to push that you want, if you can get the radical by itself, to do that. So to get rid of the 2 first. Okay, and they are our simple problems. And then we have our quadratics. And I did one. This is going to result in a quadratic. We can do this one very easily. When I do this, this is an index of a 3. I'm going to cube both sides. And I will get x squared plus 2x, and 2 to the third power is 2 times 2 times 2, which is 8. At this point, you have x squared and x in a problem, which means it is a quadratic. When we solve quadratics, we set it equal to 0, which means I minus the 8 over. And now I look to see that it's factorable, or I use the quadratic equation, which we might not have done yet. So factors of 8 plus, that will get me 2. 4 times 2 is negative 8. When I get this answer, I will get x. Remember, this might bring it back from what we did a while ago. You set them both equal to 0, and then you get x is negative 4 and x is 2. Well, since we're dealing with square roots, you definitely need to check these answers. So you're definitely going to want to put in negative 4 squared. When I do that, 16, and negative 4 times 2 is 8. Is the cube root of 8 equal to 2? Then yes, this works. And when I do the cube root of 2 squared, which is 4, and 2 times 2 is 4, then the cube root of 8 works again. So in this case, both answers are correct. This is going to be one of our more challenging problems, and we'll take a look why. This is the radical. It has to be isolated, which means we want this plus 7 out of here. So when I minus over, I get x minus 5 on this side, but on this side, this is an x, a minus 7. It can't become 7x. It's x minus 7. So the only problem is I have my radical by itself, so I am ready to square it to get rid of it. But the problem is when I do that, I'll get x minus 5, great, but now that means I have to square a group, which I don't think we've done before. And when you square a group, that means you write the group twice. So now on this side, I have x minus 5, and now if this is a binomial times a binomial, it means we FOIL. So I'm going to get a minus 7. Inside, I'm going to get a minus 7. I'm going to get negative is 49. If I clean this up, I get x squared minus 14x plus 49. But now this is a quadratic. There's an x squared, there's an x. I need to move over both of these. So in two separate, I minus x, which means it goes here. I add 5, which means it goes to this one. And now I have 0, x squared minus 15x, because minus, plus 4. So now I can see that it does work out to be a quadratic. I know that it's a plus sign and a minus, which means it's minus, something we haven't seen in a while. So factors of 54 that get me 15 are 9 and 6. 9 and 6, when I set them equal to 0, I get 9. And when I set that equal, I get 6. Again, we then have to come back and test them. So is the square root of 9 minus 5, which is 4 plus 7, 2 plus 7, does that equal 9? Yes. 6 minus 5 is 1 plus 7, is that 6? Is 1 plus 7 equal to 6? The answer is no. Therefore, 6 is not a solution, and that's why we check for extraneous solutions when we're doing quadratics. So you have to check all answers when you do this. To try, this is not a quadratic, this is just easy. Square, it's 4r minus 1 equals 3r, and you would solve. This one's gonna be a quadratic when I square. So, but you're gonna get 9 squared on both sides, so that one you can work out. What I'd like you to do is take a second and try this one, in which you square this and you square this, which means that, which means 3 minus x and 3 minus x. So if you would you take a second and see how far you get on that? Please pause the video and give yourself a second to try it. Here, at least where you got 9 minus 6x, if the x squared here is larger than this x, then I'm going to move everything over. So I'm going to move, I'm going to get x squared, I'm going to add the 6x over, and then I'm going to subtract the 9, which gives me 15. And now I'm at factors of 15. When I minus 9 over, it is 16. Factors of 16 that get me 6 would be your 8, and then a 2. When I solve them, I get negative 8 and positive 2, and I need to check. I can already see that I'm going to have an issue. When I put in the negative 8, yes, I'm going to get 121. I'm going to get 16 times 2. I'm sorry, 64, 128, 128 minus 7. So, but then I'm going to get, 3 minus a negative 8. So I get 11 equals 11, and that does work. Then I'm going to get 4, 8, square root of 8 minus 7 is 1. 3 minus 2 is 1. They both work. So in this case, even though it's negative and there's radicals, it does